Hi everyone, we have two problems here. Put them on the same video. The first one is, for what positive numbers will the cube of a number exceed 4 times its squared? So let's let x be the positive number. So be positive number. Then let's write this out. So basically it's saying the cube of the number, the positive number, exceeds 4 times the square of the number. And then if you move it over, you get x cubed is greater than, x cubed, subtract 4x squared from both sides, is positive. And then for this one, for what positive numbers this should be will, the square of a number exceed twice the number. So the same thing, we're going to let x be the positive number, and you're going to get the square of the number exceeds twice the number. And so then if you move that 2x to the left-hand side, set that to be positive. All right, so these are the two problems we're going to be working on. So for the first one, we look at the first one. To factor out, we had x cubed minus 4x squared is positive. So factor out the x squared, and you get x minus 4 is positive. Okay, so our zeros, we don't have any undefined. This is not a fraction. So we have a 0 at 0 for this one and 4 here. So we do our intervals. We want to do a number line. Let's say from 0 and 4. And this goes to infinity and negative infinity, and this goes to infinity. So you do your intervals based off this part, which is negative infinity to 0. And then this part, which is 0 to 4. And for the third part, 4 to infinity. All right. Now just choose a number here. So I chose number 1, negative 1, 1, and 5. Always kind of choose close to this number if you can, depending on your equation. Now you plug it in this number into this, and when you plug that in negative 1 into your f of x, f of negative 1, you're going to get negative 5. And let's plug in f of 1. So this was negative 5. You plug in f of 1, you're going to get negative 3. And you plug in 5. And if you plug in 5, you get 25. Well, this is a negative number, this is a negative number, and this is a positive number. What we want is positive. So we want to take this one. So basically the solution set is x such that x is greater than 4. And that's your solution set. All right, and the next one, we had this one. So if I factor that, I'm going to factor out of x, you get x minus 2. And we want this also to be positive. So our zeros are 0 and 2. Let's write it like this. Our zeros are 0, comma 0 and 2, comma 0. So if you do a little number line, we go to 0 and 2, and this side's negative infinity, and this side's infinity. So just make your intervals as negative infinity to 0, 0 to 2, and 2 to infinity. And choose values here. So I chose negative 1, 1, and 3, and plug in this equation. So we plug in f of negative 1. When I plug that in, I get 3. Plug in 1. Plug in 1. I get negative 1. And if you plug in 3, you get 3. So we got negative 1 and 3. Therefore, this number here is positive, this number is negative, and this number is positive. and we want positive. So our solution set, if you look at this part, that's where x is less than 0. Or we have this one, x is greater than 2. Or again, you could just write it your solution set also like this with the union sign. You could just copy down this right there. And that's it. Thank you. Have a nice day. Bye-bye.